In this lesson, we're going to look at how atomic structure varies in the first 4 periods of the periodic table. So what we're going to do is we're going to just look at the atomic structure in these elements. Period 1, that's in the first shell, we'll look at that in a minute. Period 2, second shell, period 3, and period 4 in the fourth shell. Okay, so the elements that we're going to be looking at are these. And just to remind ourselves, in each of these atomic diagrams, the central dot is the nucleus, and around the nucleus we've got the electron shells. Okay, these are the energy levels in which the electrons orbit the nucleus. Okay, so first of all, what I'm going to do is I'm going to look at how many protons there are in each nucleus, see how that varies across the periodic table. Remember that we're looking at the Z number, that's the atomic number, or proton number, and we'll see how that changes as we move across each period. So to start off with, hydrogen, which is the simplest element of the periodic table, the simplest atom, that has 1 proton, okay, and it is the first element in the periodic table. Then after that we've got helium, that has 2 protons in its nucleus, and then lithium 3, and beryllium 4. So immediately you get the pattern. Each time we progress from one element to the next, we increase the number of protons by 1. Alright, so that's very easy. And as a result of that, the number of protons in the nucleus is the position of the element in the periodic table. So for example, Mercury, which has 80 protons in its nucleus, is positioned at position number 80. Anyway, so let's just fill that in. And then finally, in period 4, we're going to look at potassium and calcium. So we've only gone up to calcium here because for what we're about to do, things tend to get a little bit more complicated after we go past calcium. So that's kind of, A-level territory. But for GCSE, IGCSE, we need to know the electronic configurations for up to calcium. Okay, so that tells us the number of protons in the nucleus. The proton number identifies the element. Now, I'm not going to look at the nucleon number here. What we're interested in this lesson is the electronic structure of the atom, how the electrons fill each of the electron shells. So let's look at that. So what's going to happen, first of all, we remember that for every proton there is 1 electron because the atom is neutral, and so the protons are balanced by electrons which are whizzing around, orbiting around the nucleus. So hydrogen is 1 proton, so it will have 1 electron. Let's draw that there. And then helium has 2 protons, it has 2 electrons. Now you remember from the previous lesson that we said this is the first shell, and the first shell only has a capacity of 2 electrons. So once we get to 2 electrons, once we get to helium, that shell is filled, and we now start filling a new shell, which means we go to a new period or new row in the periodic table. So let's just do lithium here. We've got the first shell is filled, okay, and now lithium will have 1 electron in its outer shell. Now I'm not going to bother filling in the shells as we go across this period. You can assume in each case that the first shell is filled, okay, in each element, and the same applies to the next row. Okay, so beryllium will have 2 electrons in its outer shell, boron will have 3, carbon will have 4. After that, something interesting happens. What actually happens is the electrons like to pair up. Okay, that's a quantum mechanical effect. You don't need to worry about that, but you just need to know that as you're filling in the electrons, that they will tend to pair up once you get past 4 electrons in the outer shell. So nitrogen will have 5 electrons, and then an electron pair there, they pair up. Then oxygen, 6 electrons, fluorine, 7. Okay, we've nearly got a filled shell. Next one in the list, neon, we're in the inert gases. here the outer shells are complete. Okay, so we've got 4 electron pairs, that's giving us 8 electrons, a completed octet. Okay, we then go back down to sodium. Again, as with lithium, these inner shells are now filled. This one's got 2, this one's got 8, and we start filling the outer shell again. So we're going 1, then magnesium 2, then aluminium 3 electrons, then silicon 4, phosphorus 5, pairing up there, sulfur 6, and then chlorine again 7 electrons, and then finally argon, again a completed octet. Okay, just to finish off, down at the bottom we've got again potassium and calcium. Well, again, all completed shells on the inside, 1 electron in the 4th shell, and calcium 2 electrons in the outer shell. Okay, and that's where we stop. Now then, the last thing we're going to do in this lesson is we're going to talk about the electron configuration. Okay, so the electron configuration, which is sometimes called the electron distribution, just tells you how many electrons are in each shell. Okay, so in the case of hydrogen, it's simple, you just write 1. Okay, and for the case of helium, 2. Right, now lithium, okay, we've got 2 in the first shell, and then we put a dot there. Some syllabuses they put a comma, it doesn't really matter, and then 1, and so that's 2 electrons in the first shell, 1 electron in the second shell, and then beryllium, 2 electrons in the first shell, 2 electrons in the second, and then boron 2.3, etc. 0.4. Okay, so that's the electron configuration for the second period, the second row. And then after that we're going to go to first shell filled 8, second shell filled, and then 1 electron in the third shell for sodium. And then again, same for magnesium, 2.8 filled, and then 2 electrons, etc. And then finally down to potassium again, inner shells filled, that's 2.8.8, okay, 0.1, that's first shell filled, second shell filled, third shell filled, fourth shell 1 electron, 2.8.8.2. Okay, so just to finish with, in a GCSE or IGCSE exam, for example, you might be asked this type of question, which element has the following electron configuration, 2.8.4. So what you do in this case is simple, you just add up the electrons. So you would just do the sums, 2 plus 8 plus 4, that gives you 14. And so that tells you this is the 14th element in the periodic table. You look on the periodic table and you find that it is silicon. So don't get fazed by the structures, just simply add up the numbers, calculate the number of electrons, and find out where in the periodic table it belongs.